Homework M1. In question 1a we are given a lot of information to describe a beam AB, its length, where pivots are, and a child of mass 50 kilograms standing at two different places. I'm not going to read the whole thing out. I've summarized the information into two diagrams where the child is at point A and when the child is at point B. We are told that this is a non-uniform rod, so we don't know where its center of mass is. We need to measure a distance from a particular point. Now ultimately we do need to find the distance of the center of mass from point A. So some people, including the mark scheme, will have put the entire length here as x. I however have chosen to measure x from the point P. It fits in better with my diagram, and I felt that when the working comes out it simplifies a little bit easier. But what I do need to remember is at the end of the question, to actually find the distance of the center of mass from A, I'm going to have to take my value of x and add 2 to it. Now, the other important things to note when I've created the diagram is that when the child is at different places on the bar, the resultant forces, from points P and Q are different from each other. This is most evident that when the child is at point A, RQ is 0, and when the child isn't at point A, RQ is not 0, and same with P. That's why I've called them RP1, RQ1, RP2, and RQ2 in there. We've got a lot of variables here. The easiest thing to do is to pick points that will eliminate as many of them as possible. So from this first diagram, when the child is at point A, I'm going to choose to resolve moments about point P. This eliminates RP1 from my problem, and RQ1 is currently 0, so that's not part of my problem either. Instead, I have all my clockwise measurements, which is xmg, equal to my anti-clockwise moments, which is 2 times 50g. xmg equals 100g, or simplifies to xm equals 100. I'm going to leave that alone for a moment. On my second diagram, to do the same thing, I'm going to take moments about point Q. Again, RP2 is currently 0, RQ2 can then get eliminated from my problem. Clockwise, sorry, I'm missing a distance there. That one is length 3. Clockwise, 3 times 50g is equal to anti-clockwise 10 minus x, lots of mg. If I expand that, 150g equals 10 mg minus xmg. All those terms have got a g in, so I can cancel that out. And I got xm. This is the reason why I chose x to be what it is, because from my first diagram I just had a straight up measurement of x. It wasn't x take away 2 or anything equivalent. It gave me straight thing xm, which I can now substitute into this problem. 150 is equal to 10m minus 100. So 50 is equal to 10m. Sorry, 250, sign error. 250 is equal to 10m, so m is equal to 25. Okay, the mass of the beam is 25 kilograms. I'll put some units in. That's one of the two things that I needed to find. Now I need to find the distance of the center of mass. Well, x times 25 is 100. So x is equal to 4 meters. However, as said at the beginning, what I needed to actually find was the distance from A to the center of mass. So distance from A equals 6 meters. And that's my final answer. In part B, we need a new diagram based on the new position that the child is standing on. This time the beam is in equilibrium from a point X on the beam. Now again, I can choose where I measure the point X from. This time, because I know that I'm going to be taking my moments around point A here at the end of the beam, I've decided to do X all the way across. I filled in all my lengths this time across the beam, and I've taken the information that we had from before. I know what the length X is to the center of mass of my beam, and I know that my beam has a mass of 25 kilograms based on my work in part A. Once again, we're going to create simultaneous equations. First one is going to come from just resolving the upward forces against the downwards forces. So upwards I have 2r, Downwards I have 25g plus 50g. That's the beam and the child. So R is equal to 75 over 2g. And I'm just going to leave that for the moment. The next equation I'm going to take is from taking moments about point A. I could do this about B as well. I don't want to do it around either point P or Q this time round, really, because the fact that the resultant forces are, no, it is reaction. The fact the reaction forces at P and Q are the same is important, so I don't want to eliminate either of those from my problem. So, going clockwise from point A, I have 6 times 25g plus x times 50g is equal to my anti-clockwise forces, which is 2r plus 12r. So that's 14r in total. Well, I know what r is. R is equal to 75 over 2g. So I can fill that one in there. And I can simplify this bit, that I've got 150g, and I have 50xg. Now, every term's got a g in it, so I can eliminate those. If I simplify, 150 plus 50x is equal to 525. 50x is equal to 375, and so x is equal to 7.5 meters.